Couldn't find good videos for this exact thing that I am attempting to show you. And what I want to do today is we are going to take a normal distribution and we're going to kind of work backwards. We are going to try to find the value, the sort of x value that corresponds to a different percentile. So let's make up a situation where, for example, we are going to have a distribution of grades that have some standard deviation. I'm going to say, let's imagine it is normal. So we're going to say D for our distribution is equal to normal distribution, normal dist, and you see it becomes an unitalicized normal dist, parentheses, and we're going to say, let's say the average is a 90 and the standard deviation is 2. Something like that. And of course we see, oh, we've got a flat line here that's not very interesting, but Desmos is great. We can hit the little zoom fit button right there, and there's our zoom fit, there's our curve. Normal curve like we're used to seeing, single peaked, symmetric, so great. We're looking good so far. And we can ask ourselves a question like the following. What if a student is scores in the 81st percentile, what is their actual score? Now what you can do with these other videos, things you've seen before that I didn't have to make, is it's very easy to say, like, if a student scores an 86 on the test, what's their percentile? That's gonna just be a more straightforward one. That one you would just click the find cumulative probability, parentheses CDF, which stands for cumulative density function. But that's not what we're doing here. Instead, we're saying, I know the percentage. I know that 81% of the people did worse than this student, but I don't know the actual score. And so what we're going to do here is we're going to do the following steps. We're going to do D, because we're doing that distribution, so it's this letter D. If you would call this something else, you would just call it whatever you called it, dot, and then we're going to do inverse CDF, which like looks italicized until you finally type this whole thing out. So if you mistype any of the letters, it's going to get messed up. But inverse CDF, we're going to do parentheses, and we want to figure out the 81st percentile, so we're going to do 0.81, because that's going to tell us the score where 81% of people did less than that number, and it's spitting it out. It's telling us that it's 91.755792591. And so we can do that. We can check that this indeed works. Let's do that over here. Let's find the cumulative probability for this normal distribution, and let's type in that number we have there at the bottom, 91.755792591. And we see all this space highlighted, and it's telling us that that shaded area underneath this curve is 0.81, which is the probability that a randomly selected score from this distribution is less than 91.7557, and that probability is telling us it's 0.81. All right, so it's this idea of an inverse CDF. It's the one that's taking the percentile and giving us the value along the axis, as opposed to what we did before, where we had the value along the axis and figured out the area underneath it. Now we could do other things too. What if we wanted to find the quartiles, Q1 and Q3, for this distribution? All right, well, luckily we've got this normal distribution already given here. I'm going to take that away. Oh, not that part. I'm going to take away this part. So if we wanted to do this, we'd say, okay, I need to know the 25th percentile and I need to know the 75th percentile. And so we could say D dot inverse CDF. So inverse CDF is the general command. The D is because we've defined the distribution up here. And parentheses, well, the first quartile is what percentile? 25th. So we would do 0.25. Actually, I imagine if you just typed in 1/4, that would work as well. And it does. But let's do 0.25. And so we get this 88.651. So the first quartile is 88.6510. And we can also do D inverse CDF, parentheses 0.75, because the third quartile is the same thing as the 75th percentile. And so we can get that value of 91.3489795004. Awesome. if we want to kind of check this, we know that the percentage in the middle between these two quartiles better be that middle 50%. But we can do that. We can click find cumulative probability parentheses CDF, and let's type in these two values we got down here for the first and third quartiles. We'll do 88.651. We're not going to do it perfectly. I'm not going to type in all those decimals. And 91.349. And we can see we get this like nice middle part. It's symmetric in there, and we see that that is really close to 1/2. And the little bit of error down there in those, 10 thousandths and millionths and all that stuff is just from rounding errors because we didn't type in the whole numbers there. So we get that middle 50%. We can figure out our quartiles with this inverse CDF. And so, Desmos makes this really easy. The video for how to do it on your calculator is up there as well. Good luck. Can't wait to see you all again.